All right, so the next thing that we're going to talk about is similar to the segment addition postulate. I'm going to do this on a different sheet. But it is called the angle addition postulate. Now recall that the segment addition postulate said if we have two segments that make up a bigger segment, we can add the length of the two small ones and get the length of the big one. Okay? Works the same with angles, but we have a little bit different notation. So we're going to say M, which means the measure, that's what that little m is, the measure of angle ABD, which is this one, plus the measure of angle DBC, should equal the measure of angle ABC. So if I either have numbers or expressions to represent these angle measures, I can set up an equation just like I did with the segments. Okay? So this is how that would look. So if I told you the measure of ABD was 60 degrees, and the measure of DBC is 15 degrees, and I want you to find the measure of ABC, and how did you get 75? Those of you that are visual, you might want to label. If I know ABD is 60, I'd put that there. And DBC is 15, I could put that there. And then looking for the whole angle, I know I'm going to do 60 plus 15, which gives me 75 degrees. Okay? Now those are the easy ones. When it's just numbers, those are pretty basic. You probably did do these in your head. Okay, another one that's almost as basic, but you really need to watch what you're doing. If I told you the measure of ABC is 70 degrees, and the measure of angle DBC is 10, and I want you to find the measure of angle ABD, you're going to have to subtract because they're giving you the big angle in this case. So when they give you the big angle, since you can't label in the middle and know which one for sure it is, I would suggest that you put a little arc on the outside and say, okay, I know all of this is 70. I know this part of it is 10. So to find this part, and if you like using variables, I could throw X in here and use a variable. I'll do that just in case. But he said you're going to end up subtracting, okay? But I could say, okay, well, X plus 10 equals 70. And there's where my subtraction comes in. If I subtract 10 from both sides, I have 70 minus 10, so that would be 60 degrees. That's another fairly easy one. For the next one, we're actually going to pull one out of your homework. And number 42, 43 is off of the same diagram, but you really need to label what you have and figure out what's going on in your picture. But I figured we might as well do a homework problem. right. When they use the same diagram for more than one problem, sometimes you need all the markings, sometimes not. Okay, so this is what your problem would say. We have expressions for 3 different angles. And they want us to find x and then the angle measures. So you have to set up an equation to solve for x before you're going to be able to plug x in and find the angles. We don't use them in this particular problem, but what are these 2 arcs for? Any ideas? Do you remember on the segments when we had the midpoint, we had the little tick marks? And it showed us what 2 pieces were congruent, right? Well, it's hard to use a tick mark in an angle and know which angle you're talking about. So if they're trying to show you that 2 angles are congruent, they're going to use an arc. Okay? In a diagram, if you see that 1 arc has been used and then you see a set of 2 arcs, like a double rainbow type of thing, that means that those 2 angles are congruent. So you can't say one pair is congruent and then turn around and use the same marks for another pair. Okay? Yeah.
So AOD and COD will be the same?
Yes. So those 2 angles are supposed to have the same measure. Now, once we get into, the only time you're actually going to physically take out a protractor and measure an angle is if they tell you to get out a protractor and measure the angle. For the rest of what we're doing, we're actually using their measurements and their algebraic expressions to set up equations. So their disclaimer usually on these problems is they're not to scale. If you were to bust out your protractor and measure it, it probably would not come up to what they're saying it is. So you're not meant to do both, okay? We're specifically using what they give us with algebra to set things up. But here's where the labeling comes in handy. Okay, I'm going to look at AOC and say, oh, that's this big one right here. So I would draw this line over the 2 to know that that whole angle is 7x minus 2. AOB is 2x plus 8. That's this little guy right here. And BOC is this one, that's 3x plus 14. Okay, the first thing you're going to want to notice once you get it labeled is we don't need this one over here at all. That's actually there for a different problem, maybe even 43, okay, but we don't need to worry about that. So we could do this problem without that completely. You guys see that? So now you're going to say the 2 small angles add up to this big one, right? I could use this angle addition postulate, but basically what I'm going to get is 2x plus 8 plus 3x plus 14 should add up to 7x minus 2. Okay, and that would be substituting into the angle addition postulate, all right? The rest is algebra, so I have 2x and 3x would be 5x. 8 and 14 gives me 22. Now I would subtract 5x, so I have 22 equals 2x minus 2. Add 2, so 24 is 2x. Divide 2, and x should be 12. Okay, that takes care of my variable. But I need to find these 3 angle measures. Okay. Oh, yeah. So I could come up here and plug in one at a time to make sure I get all three. Okay, in fact, let's do that. So this would be 7 times 12 minus 2. So 84 minus 2, yes, makes that angle 82. This would be 2 times 12 plus 8. So 24 plus 8 is 32. And 3 times 12 plus 14 would be 36 plus 14 would be 50. And the nice thing is, if you do take the time to plug into all three, aren't these two supposed to add up to that? It's a good way to self-check. Now I could, if I found the two smaller ones, I could turn around and just add those two numbers together, but if you did a little bit of math wrong, then your sum is going to be wrong, right? Where if you plug into each expression, you should be in good shape. And then you can check and make sure they add up like they're supposed to. Okay, good self-checking tool. So here are angle measures. So that is the angle addition postulate. Okay. Anyone still writing, or are we good so far? All right. I'm pretty good on time. Okay. We have some angle pairs that you need to learn or identify. The first set, I need you to draw two intersecting lines. Okay. These are going to be where we find vertical angles. They are not next to each other. Sometimes people refer to them as opposite angles. Only found with intersecting lines. Okay. The reason that's important is a line with a ray coming off of it will not give you vertical angles. Okay. If we number these, the other thing to know about vertical angles is they are congruent. Okay, there actually is a theorem that talks about that. So if I wanted two pairs of vertical angles in this diagram, the first pair would be 1 and 3. And of course the other pair would be 2 and 4. Okay. So with intersecting lines, we get two pairs of vertical angles always. Okay. We also need to talk about adjacent angles. Here, angle 1 and angle 2 are adjacent. angle 3 and angle 4 are adjacent. So they'd be side by side. They share a ray in the middle. Kind of like neighbors that share a lot line. Okay? If you and someone next to you share a lot line, that would be the house adjacent or the lot adjacent to your lot. Okay? But they also have to share a vertex. So no gaps, no overlaps. So if I had something going on like this with a gap in the middle, these two angles would not be adjacent. If they overlapped, like so, they would not be adjacent. Okay? They share one side in the middle. They share a lot line. Okay. And there are two other pairs. You might have heard of them. Sometimes people have at this point. People sometimes get them mixed up. We have complementary and supplementary. So complementary add up to 90 degrees. Okay, now I draw them this way so you can see the right angle, but if I took angle 1 and angle 2 apart, they still would add up to 90 degrees. They still would be complementary. Okay, so any two angles, you might want to put that in there. We only talk about pairs as being complementary. So if you have three angles that add up to 90, those are not complementary. Okay. Supplementary are two angles that add up to 180 degrees. Visually, if you put them together and they form a line, they're supplementary. But they don't have to be together sharing the same vertex to be supplementary. It has to do with their sum. Okay. How many of you have heard of complementary and supplementary before today? Okay. If you're like most people, you might struggle with which one is which. Okay. I had a student once I thought was pretty clever. They told me that the C, if you put a line through it, makes a 9 for 90. And the S, if you put a line through it, gives you the 8 of 180. That's how they remembered. Personally, I always figured C comes before S in the alphabet, and if you plopped it down on a number line, 90 comes before 180. Okay, that was my tool for memorizing which was which. Okay, but you're going to have some diagrams, and you'll be looking for these pairs. Okay, I wish we had a little bit more time to do examples today, but try it on your own. Come in with questions tomorrow. Okay, you'll probably know these pairs better at the end of the semester than you will when you take the test on it, because we use them a lot. Make sure you get your stuff organized for the homework quiz, because again, that's going to be the first thing we do tomorrow. 1-6 will not be part of it because we won't have corrected it yet. Okay. Homework tonight is on your blue sheet for 1-6.